So you've got the model there, which is one of the fixed ones. You have to set up what the different machine joints are going to do. So there's a list here. Okay, to do this, I have to edit it. So it's telling me I have to save the thing as my own copy. So I'm going to do that. So it's a little bit weird, this 3D simulation, because it doesn't form. It is in the project. It's part of Motion Perfect, but it doesn't save it as part of the project. It saves it as its own file. So here it's saying put it on the desktop, which is probably not the greatest place to put it. So I'm going to put it in my projects folder. So we'll do that. Call it Gantry 1. So I've just saved it, basically saved a copy of that. So you can see on the left hand side there's 5 what we call joints. So these are joints that actually exist or could exist on this, and I have to actually set those up. So if I open that, you can see this is called joint 0. So it's giving me where the joint is, X, Y and Z, and its orientation. That would form, if it's a rotating axis, you know, it would tell you which direction it's rotating in, whether it's rotating against the Z axis or the X axis or whatever. And the negative on the Y there means it's orientated sort of going the opposite way. And then you've got the movement here and a little slide bar, so you can actually move the thing about. So that's moving that one there. Okay, so this is, if you start up with your own model, you've got to actually add these things in yourself. You've got to actually tell it which part of the model is this joint. So maybe if I just retract back from that a second and look at the actual model itself. So here, what this is saying is we've selected, within that 3D model, there are different components, and they're all listed on that right hand side there. So if I look at any of them, it'll show me what they are. So that object is that bit, that's that bit. So obviously I'm not going to animate those, they're just part of the model, so I don't really want those part of the animation. That's a slider, that's fixed, that's the other slider of course, that's the base, so nothing there to animate at all. But the parts I do want to animate, I basically get that, I'm going to have that part. It looks like in the model the left hand slider is actually also part of the crossbeam. So that's just how the CAD drawing is. Yeah, so different CAD drawings will be done in a different way. So all of that, basically, those two objects fit with the requirements for this part that we want to move and slide. Okay, so they've been selected. If I did select another bit like that, and then I went to the movement, obviously it's moving anyway because it's carried on there. But if I did that, it would mean that I was effectively carrying something that I don't need to on here. So that's that part, and then you do that for every axis basically. So I've got another one there, and the model parts for that one are there and there. I think that's all for that one. So that part there is just close that in joint 0 a second. So that part there moves that way, going along there. I guess, yeah. So this part here must be carried up and down, which is why it's not part of that model. So you've also got, so that's its location at the moment. I don't know if I move this, if it doesn't move around. So this is the location of it within the drawing, the original drawing. And you see it's got a parent. So the reason it's carried by the first joint is because it's got a parent joint. So I can say, right, this joint 1, which is highlighted yellow at the moment, it's got a parent joint 0. So effectively, whenever I move joint 0 around, it will carry that one with it. So there's a hierarchy between them. Yeah. So that's that one, and then the next one, of course, will be some more parts of the model, which is the vertical bit that goes up and down. And if I look at that and move it around, it's going up and down. You can set ranges on this as well, so you can actually set the ranges, and everything's really is effectively in millimeters. So all of these things are in millimeters, and the dimensions come from the drawing. There's no way to kind of rescale this. So if the drawing is something that's a certain size, then that's how big it will be. You can't take a gantry that is 200 millimeters long and say, okay, I want to represent a 400 millimeter gantry, unless you do it in your head and say, right, I'm just going to double everything. But the drawing is the drawing, and that's just how it is. This is a fixed model, yeah. So if you use your own model, you have to generate the model in the CAD system, import it as an OBJ file. Yeah, and what you sometimes find, we looked at a model that someone had done at one point. Just wondering if there's an example here. So that's that. Yeah, so you see there's even, like, sometimes you get some models and every single nut and bolt is a separate item, and then you have to kind of group them together and animate that as a group. That can slow down the animation. If it consists of a lot of separate parts, it can slow down the animation. So you've got to be a bit careful of that. And conversely, the other way around, we had someone recently who provided a model where the whole 3D model was one object. Well, if it's one object, you can't separate parts out and animate them because it's one object. So it needs to be kind of thought about. Usually there's one OBJ file and one MTL file for the materials, and then it kind of
and then break it down from there.
Yeah. You tend to find if it's going to work, when you open this up and you kind of look at that and look at the model parts, then you've got the list of all the objects from the 3D drawing.
Right.
If there's only one object, you're screwed. It's not going to work. If there's 1,000 objects, you're going to be busy. All you can do is take the CAD drawing that's been given to you and animate it. You can't change anything in it or manipulate it particularly, as far as I know.
Can the Motion Basic program actually move that?
Yeah, so having done that, if I look at these labels here, look, I've got those joints. Okay, we've ignored the third and fourth because that's an animated axis that rotates the tool tip. Well, we'll leave those alone for the moment. But literally what I do is say, okay, there's joint 0, I'm going to bind it to axis 0. Axis 0 depots, yeah. And that one, I'm going to make that axis 1 depots. And that one, I'm going to make it axis 2 depots. And now I've joined them to axes within the controller. This is actually running some live axes, isn't it? So I'm not sure how wise this is, but anyway, we'll carry on. So having decided what axes I'm going to join them to, I say the thing then is you obviously got to scale the movement you're going to do to suit the actual modle. To tidy this up, I can move those off to the side so that they're not in the way, but they still exist there. Look, so it's just put them in reverse order for some reason. And then in theory, if I animate it now, okay, it's jumped off to one side because I'm thinking that's where the axes are. So where's the axis parameters? Look. Running the animation once it's running does tend to slow things down. I don't know if you noticed, but that took a little while to populate the values in there, because you are actually loading up the comms between the controller and Motion Perfect quite heavily as it tries to animate the drawing. So where's our deposits? So our positions are down here. So this one's at 4946, which is why it's WASD off to the end. So if I go in, let's just move this a little bit. If I go in terminal 0 here and do base 0, okay, and then I do a def pos 0. There we go. So that's jumped back to the middle now. So all it's doing is following the deposes. So if I do a def pos or a move, it does the same thing. So if I do, is the servo on everything? I'm not sure. How enabled are we? We're not enabled. Okay. So if I enable, because I picked axis depos. This is for robots.
Oh, yeah.
I should have picked depos.
Yeah.
The axis depos uses axis units,
Right.
and axis units will still be one.
One.
But we haven't covered that. That's a robot thing.
Okay.
Yeah. So that's the explanation for that. So now it should. There we go. It's moved 10 millimeters, which is what I thought it would do. There you are. So you see it's moved like that. -5 goes the other way. And you can change your view. You can look at it from different angles. You can zoom in.
And as you said,
So it's updating the model at 16.9 milliseconds. And that's just due to the speed over the Ethernet. Yeah, so there it is.